Hey guys, I know it's only halfway through the day, but I got questions on 3, 9, 11, and 12. So I got 3 drawn here. Given this picture, given the information, dx dt, dl dt being half of dw dt, and so on. So they want to know what dl dt is at the instant when L is 8 and W is 6. So the equation that we're going to be differentiating, L squared plus W squared equals X squared. 2L dl dt plus 2W dw dt equals 2X dx dt. And when L is 8 rather, and W is 6, that's 8 squared plus 6 squared equals, just to figure out what X is. So 64 plus 36, that's 100, so X equals 10 at that moment. So we found that out. And we can substitute out the dl dt for half of dw dt in order to solve for it. So we have 2, L is 8, dl dt is 1/2 of dw dt, plus 2, W is 6, dw dt is, again, we don't know, but that's what we'll be solving for, equals 2, X is 10, dx dt is 1/5. So when I clean that up, the 2 and the 1/2 cancel, so we got 8 of these plus 12 of these, which makes 20 dw dt's, equals 20 times 1/5 is 20/5, which is 4. So dw dt is 4/20 or 1/5 also. If dw dt is 1/5, half of 1/5 is going to give you a dl dt of 1/10. So on the multiple choice, that is option B for number 3, 1/10. If I jump to number 9, now you're going to have to bear with me because I haven't read this or set it up. So we'll see what we have 2 trucks starting from the same point. One truck is traveling due east, going that way at a rate of 50 miles per hour. The other one's going due north. We'll call that Y. At a rate of 60 miles per hour. At what rate is the distance between the 2 vehicles increasing? So we're looking for this rate, so we'll call this Z. And so we're looking for dz dt. At what rate is that increasing? 1.5 hours later. Okay, so if they started at the same point, the 1.5 hours is going to give us this length. So they want at the moment of the 1.5 hours. Well, if this one's been traveling for 1.5 hours at 50 miles per hour, then this guy is 75 miles away. If this guy, remember they started at the same point, so they've both been going for 1.5 hours, but this one's going a little bit faster, 60 miles per hour, so 1.5 hours would put that at 90 miles away. So at that moment, 75 squared plus 90 squared equals Z squared. At this moment that they're interested in, 90 squared, so I'm definitely going to use a calculator here. Oh boy, it's not a pretty number. Z is the square root of 13,725, which I'm sure 25 goes into that if I want to. 25 goes in at 55 times, so 25 times 55 would be 5 root 55 equals Z at this moment. But everything's changing, so when we differentiate x squared plus y squared equals Z squared, 2x dx dt plus 2y dy dt equals 2z dz dt, and we do our plugins. So 2 times an x of 75 times a dx dt of 50 plus 2 times a y of 90 and a dy of dt of 60. 2 times a z of 5 root 55 and a dz dt is what we're looking for. So this is 100 times 75 would make it 7,500 plus 120 times 90 is going to give us 10,800 plus the 7,500. That gives us 18,300. And I'm going to have to divide that by 10 root 55 when I divide that over. So the 10 would cancel out and it would be 1,830 over root 55, which is approximately 246.76. Which is not correct. What did I do wrong? 1.5 hours later. 1.5 hours of going that speed would be 75. 1.5 hours going that speed would be, oh, I used the wrong number. But still, mine are so way off. 90. Oh, no, that's right. 1.5 times that would be 90. 75 squared plus 90 squared. 13,725. Maybe I'll just call that, x squared plus y squared equals z squared 2x dx dt. Root 55 dz dt. So 2 times 75 times 50 plus 2 times 90 times 60 divided by 10 root 55. Oh, I didn't break that down right. 25 times 55. Oh my gosh. Sorry. I didn't break this down right. Why don't I just leave it the square root of, this would be a calculator problem anyway, the square root of that, and then I would divide by 2 root 13,725. So 18,300 divided by 2 times root 13,725. Okay, more like it. 78.1. Which, I'm looking at number 9, is option B. All because I broke down wrong. Son of a gun. You look at the options for that, since there are decimals involved, like you can kind of gather that a calculator is allowed there. Number 11, we've got point P, X, Y moving in a counterclockwise direction on the top half of the unit circle. Okay, so here's my unit circle. That's going to be like 1, negative 1, 1, negative 1. Point is XY is moving counterclockwise that way. If the x coordinate of P is D, so we're going to really make a right triangle out of this. X comma Y. So this is X, this is Y. dx dt, it says if the x coordinate is decreasing at a rate of 1/10, so that would be negative 1/10 for dx dt. At what rate is the y coordinate changing when point P determines an angle in standard position of pi over 6? So when this is pi over 6, now pi over 6 is 30 degrees. Couple ways you can do this. You can use some trig to do SOHCAHTOA and find missing lengths. But this is always 1, so that's not changing. So we'll call that z, and dz dt equals 0. So x squared plus y squared equals z squared, or 1 squared here, which is constant. So when we differentiate, it's going to be 2x dx dt plus 2y dy dt equals 1. So at the moment that that reaches pi over 6, your y is the sine. So the sine of pi over 6 is the sine of 30 is a half. And your x is your cosine. So the cosine of 30 is root 3 over 2. So 2x is root 3 over 2. dx dt is negative 1/10. Plus 2y is a half. dy dt is what we're looking for. Oops, that shouldn't have been 1. I always do that. Differentiating the constant gives you 0. Equals 0. So when I go to solve this, those 2's cancel. This is negative root 3 over 10. I'm going to add it to both sides. So it's positive root 3 over 10. 2 and a half cancel. dy dt equals root 3 over 10. Which is option D. 11 is D. And then the last one, 12. 2 ships leave port at the same time such that the angle formed by their sailing routes is 150. Oh, this one we're omitting. I said in the video that this one needed a law of sines, law of cosines, which you guys have never done. So, that's it. Just those 3. Sorry about the hiccup on number 9, because I didn't break down my radical right, but hopefully that helps. Have a great weekend. We're done with related rates. We're on to the next chapter tomorrow, or Monday, rather. Have a great weekend.